our last set of nomenclature is going to be for acids and bases. And some properties of acids. They will produce hydrogen ions when they are dissolved in water. They tend to have a tart or sour taste, so think about a lemon. Aqueous solutions are electrolytes. So an electrolyte can produce an electrical current. So if you have an acid that's been dissolved in water, which is aqueous, then you would have an electrolyte. So an electrical current can be conducted. They will cause an indicator to change color. So an indicator is a chemical that changes color in the presence of an acid or a base. And they will react with certain metals to produce hydrogen gas. They'll react with certain compounds containing a hydroxide group to form water and a salt. Bases will produce hydroxide ions when they are dissolved in water. So anytime an acid reacts with a base, you're going to get water and a salt. They tend to have a bitter taste. Think about getting soap in your mouth. Bases can also be electrolytes. They tend to feel slippery. If you've ever gotten bleach on your hands, feels slippery. Bases are going to cause indicator to change color as well, and they will also react with acids to form water and salt. So bases are going to be named just like your ionic compounds. Name the cation first, then the anion, which will usually be hydroxide. There are two bases that you need to know that do not contain a hydroxide group, but they are most certainly bases. The first one is NH3, which is ammonia. Do not confuse this with ammonium, which is the ion NH4+. And the other one is NaHCO3, which is sodium bicarbonate or sodium hydrogen carbonate. It's baking soda. Chemical formulas of acids are going to have the general form HX, where you have hydrogen attached to X, and X is some monatomic or polyatomic anion. And the name of the acid will be based on the anion name. All of your acids are going to end with the word acid. So if your anion ends in "ide," like nitride or phosphide, all of your monatomic anions. The acid's going to begin with hydro, and you're going to change the ending to "ic." So you're going to add the prefix hydro to your anion name, change the end of the anion name from "ide" to "ic." So for example, HCl, our anion here is chloride. So this is our X piece, chloride. So we're going to add the prefix hydro and then change the ending from "ide" to "ic, so that we get hydrochloric acid. If your anion ends in "ite," so sulfite, phosphite, the ending is going to change to "us." So we're not going to add a prefix anymore. We're just going to change the ending from "ite" to "us." So if you have H2SO3, that SO3 group is our anion, which is sulfite. Now for sulfite and phosphite, you're going to have to bring that UR-OR piece back that we dropped. And so this is going to become sulfurous acid. So we're going to bring that UR back and then change the ending from "ite" to "us." When the anion ends in "ate," phosphate, sulfate, the ending is going to change to "ic." So to help you remember which one gets which, if you remember you ate something icky, then your "ate" becomes "ic." Again, no prefix, no hydro here. We're just changing the end from "ate" to "ic." So if you have HNO3, our anion piece is nitrate. So we change the ending from "ate" to "ic. This will be nitric acid.